Lebesgue dominated convergence theorem. State and prove the Lebesgue dominated convergence theorem. Statement: let G be an integrable function on E and let Fn be a sequence be measurable function such that modulus of Fn is less than equal to of G on E and limit n tends to infinity of f of n is equal to f almost everywhere on E. Then integral e to base of f is equal to limit n tends to infinity integral e to base of f of n. Now proof. Since we know that f is a measurable function over a set of E and there is an integrable function G such that modulus of f is less than equal to of G, then f is a integrable over E. So clearly each Fn is a integrable over E. Also limit n tends to infinity f of n is equal to f almost everywhere on E, and modulus of Fn is less than equal to of G almost everywhere on E, which implies modulus of f is less than equal to of G almost everywhere on E. Hence f is a integrable over E. Let phi n be a sequence of a function defined by phi n is equal to G. Clearly phi n is a non-negative and integrable function for each n. Therefore, by Fato's lemma, we have integral e to base small bracket starts f plus g is equal to less than equal to a limit lower limit n tends to infinity integral e to base small bracket starts f n plus g bracket close integral, which implies integral e to base f of is less than equal to of limit lower n tends to infinity integral e to base f of n. Similarly, let psi n be a sequence of functions defined by psi n equal to G minus f of n. Clearly psi n is a non-negative and integrable function for each n. So again, by Fato's lemma, we have integral e to base g of f of which is less than equal to lower under limit integral e to base small bracket start g minus f of n, which implies integral e to base g minus integral e to base f is less than equal to integral e to base g minus limit lower n tends to infinity f of e f of n, which implies minus of integral e to base f less than equal to limit lower n tends to infinity integral e to base f of n, which implies integral e to base f is greater than equal to limit upper of f of n f integral e to base of f of n, which is equation 2. Hence from 1 and 2 we get integral e to base f of limit lower f e to base f of n is equal to limit upper of integral e to base f of n. But since lower limit integral e to base f of n limit upper integral e to base of f of n is equal to limit e to base of f of n, hence integral e to base f of n is equal to limit integral e to base of f of n, which is proved the result.